tracing paper. I'm on page 219, right? You should have already created this shape because this is part B, the second part of the video. So thanks for watching. Now, connect the endpoints of the diameters. We've done all of these pieces. What do you know? We're answering part A. What do you know about BC and DE? So BC is this whole diameter of the bigger circle, and DE is the diameter of the smaller circle. Because of the way that A is positioned, A is exactly in the middle, then that means that, maybe some highlight time, AB and AC are the same length. So we're going to use that fact to say that there should be a spike and a spike on AB, AC, because they're radiuses. They're radii of their respective circles. The same thing is also true for AD. It's a smaller line, and AE is a smaller line, but they also get two spikes. They get double spiked because it's using the smaller radius. So one thing that I know then is that BC and DE bisect each other. Where does that happen at? At point A. Now, I know that because just the way that the circles were created. A is meant to be the center of the circle. So this is small circle A, and this is big circle A. And the radius and the radius of the big circle are all the same. So that's because A is in the middle. So that means that BC and DE bisect each other. What else do we need to tell you about? They're not congruent. Oh, that's true. AB is congruent to AC, but AB is not. Big old slash mark. Sorry, I see that I'm not showing you at all. AB and AC are not congruent to AD, not congruent to AE. That's because those two are congruent to each other. So maybe like we write that down. Those are different radiuses, radii of their circles. So the circles are different sizes. They shouldn't be like matching segments. All right. You've drawn 4 triangles, so use these triangles to analyze the lengths of each side of the quadrilateral. We drew 4 triangles? What are you talking about? Well, go back and watch the other previous pages. Here's a triangle. It has a matching part on the other side because of SAS. Triangle CAE and triangle BAD. You're bad. All right, these 2 triangles are matching because of SAS. Why is it SAS? Well, it's because they have sides that match, sides that match, and there's the angle between them. That's the SAS, triangle congruence shortcut. And the same is also true right here, 2 and 2 spikes. We have SAS, triangle congruence. If the triangles that match, that are congruent by SAS, like that happens, then that tells us these sides, opposite sides, are congruent. That tells us 1, 2, 3, 4. 1, 2, 3, 4. Opposite sides are congruent. That's what we're going to answer right here. We're going to say by SAS, there are 2 pairs of congruent triangles. I hope you're okay with symbols instead of words. I know I'm trying to be like abbreviated. So BD is congruent. That's this one right here. BD, oh, my face is in the way. BD is congruent to CE. And my face is in the way again. DC is congruent to EB. Okay. I got to keep going. You can pause the video to catch up and write down what I'm going. If I'm going too fast, slow it down yourself. You're in charge. Okay. Determine the measure of each interior angle of the quadrilateral. We don't have 90 degrees anymore, so this is going to be a little bit challenging. We're going to have to measure angles, but I will tell you this. The angle at angle E is going to be the same as the angle at angle D. Those 2 angles are going to be congruent. Angle B and angle C, those two angles are going to be congruent. So you just got to measure two angles. Oh, what's the number in mathematics you need to remember in order to know like how to start? 180. I only need to measure one angle. I'm going to measure angle E. I need to draw this line longer though. How's my time? I'm going quick. Okay, I need to draw that line longer so I can actually use the protractor to measure it. Center circle of the protractor goes on angle E, and then the black line of the protractor goes on EC, on that side of the parallelogram. Now, my angle is going to be different than yours, but we should be kind of close, or you should see what I'm doing and then copy it with yours. So what I did is I drew the line right here longer so that it would actually cross the outside edge of the protractor. If you didn't draw it longer, you only stopped right there, you'd be like, I don't know, 75, and you wouldn't have the actual like angle. So you got to draw the line longer. Center circle of the protractor on E, black line of the protractor on EC. This longer ray that I had to draw just for measuring is now long enough that I can go 10, 20, 30, 40, 50, 60, 50, 60. The arrow is between 50 and 60, specifically at, dude, I'm good, 55 degrees. Okay, the measure of angle CEB. Again, pay attention to the middle letter. Is the same as the measure of angle BDC, and it's 55 degrees. Together, this angle and this one are the same. And you know what I said? I said 180 degrees. Turns out the other angle is 180 minus 55. So a little bit of math over here on the side. Borrow 525. 125 is the other angle. That would be the measure of angle EBD and the measure of angle DC. I just caught myself. I caught myself because 55, 60, these are flipped. Sorry if you did this in pen. I don't know why I didn't see it, but that's an angle bigger than 90. This is an angle bigger than 90 degrees, so it's 125. It's the other number of the protractor. Haha, you got me. DCE, that's the 55 degrees. It does show up. I did do it right. I just did it with the wrong numbers. Finishing the page. Sorry, the audio is getting messed up. That's like a thing that happens. What do you know about BD and EC? Wait. Parallel. Oh my gosh, if the two lines are parallel, this must be a parallelogram. That's probably for the next video. Thanks for watching.